In our previous videos, we scraped PDFs, pulling our data from PDFs we had put into our Google Drive. And then we had cleaned up that text by creating a pre-processing pipeline to clean up all of the symbols. So we went from text that looked like this to text that looked like this. And then the next thing we did is we created a pre-processing pipeline to tokenize our words. And so we imported a number of different packages to help with tokenization and created a function that would do all of our tokenization. And here we removed the stop words. We lemmatized the tokens, so we found the root words, and we removed the digits and the punctuation and made it all lowercase. Okay. And so what we got, not stem tokens, because those just cut off words to be weird. But here we can see our tokens are the words that are in our different documents. Now that we have those tokenized words, what we're going to look at in this particular video is we're going to look at word counts. Okay, so to do this along with us, what you should do is you should go to drstephpowers.github.io/BIA. We're here where it says text mining. You will also need the PDF documents, and so make sure you download those and put them into your Google Drive. All right, here we are at word count. So what we're going to look at is we want to look at frequency of words from our list of tokens. So we have our lowercase tokens, and we're going to import pandas as PD. And from the NLTK.probability, we're going to import frequency dist. Okay, because we want to know what is the frequency for each of these tokens. So if we apply this, and I'm just going to call this WC for word count, you can call it whatever you want, but find the frequency distribution for our AI CAN dataset that is in its lowercase tokens. So what we see is that when we output this, we get a dictionary here where it has the variable AI appears 187 times. The word generative appears 150 times. Well, it's really hard to see it listed this way. I like things as tables, way easier to see. So we're going to use our pandas as PD, do pd.dataframe, take our WC, and this particular function has what it calls items. And so we're going to do dot items, parentheses, column, and then what it's going to output is it's going to output the word and the frequency as two separate columns. So let's do that. And then we're going to have it sort the values, so sort underscore values by frequency. You have to specify what column you want it to sort by. And then do you want it to be ascending? Well, we want to be descending. We want the biggest numbers first, so ascending equals false. And when we do that, we can see that there's a lot of words. Here's even a date here where it only appears one time, but we can look at the top of the list, 187 for AI, 150 for generative, 87 for tool. Okay, now we can remove some of these words. Now, if we know this document, for example, is about generative AI, and so generative and AI are appearing way more times than everything else because that was the intent of the document, and we want to kind of pull that out and look at what else is here, you can add your own stop words to the process. So if we are looking at our tokenization pipeline that we had before, what we can do is we can use not just the stop words from English, but we could add other ones. So we could say, okay, word tokenize the text. That's the original AI CAN text that we would do this to. And let's add to the stop words AI, generative, use, using. Maybe we're going to get rid of some additional symbols and things that were missed in our initial processing. Canada.ca seems to appear a lot. We don't really care about dates and times. So maybe there's some extra ones we want to remove. We have simply amended this row that you see here from the previous videos pre-processing tokenization, which of course I'm just scanning through this huge thing here. Go back, go back, go back, go back. Okay, so we're basically taking this here, and where it says stop underscore words, set stop words, we're going to add our own to it. Now, you'll notice there's also a couple things in here we don't really need right now. We don't need the stemmer. We don't need the parts of speech or the named entities for the work that we're doing. So I'm pretty sure I removed them from the particular one here. Let's just check and see what I did. All right. Yeah. So you'll notice here that I've removed the stemming because I don't need the stemmed versions. I've also removed the parts of speech and the chunking. You can see them in the previous video, and we might use those later, but simply for doing word counts, I just need the lemmatized tokens. And of course, I just need them to have the stop words removed. I need the digits removed, the punctuation removed, and make it all lowercase. So that's what this is here. So it's a new version of our tokenization here to remove some of these key basic ones that, in our opinion, add no value. So now we run it again, but this time with a token with the stop. And then we say, okay, well then take this new tokenized one, find us the frequency distributions. We can give it a different name if you want, or here we're just going to call it WC again for word count because I don't need the other version. And then I'm going to put it into a data frame so I can see it. So data frame for word count. And notice I'm going to add one more piece here, which is I am going to have it filter and show me just when the frequencies are more than 20. So I don't really care about the one random word. What I want is words that are repeated. So we're going to sort the values by frequency, ascending equals false because we want descending. But we've added this component here where it's going to filter so only those that are greater than 20. So what appears now is that the top word here is tool, then information, then institution, then federal, and so on. We can see other ones, risk, bias. So you start to kind of get a feel about what the document is about based on some of these keywords. Privacy comes up a lot. If we want, we could plot the most common words. And so we're going to import matplotlib. We're going to do a dot plot from this table here, which was our top underscore WC. And on the x-axis, we are going to put the word. And for kind, it is going to be a bar. Okay. We are going to have the X label be words, the Y label be count. And because these words take up space, we're going to actually rotate the labels on the x-axis 90 degrees. We can make it 45 if you want. All right. Didn't work. Why? Because I didn't import matplotlib.pyplot as PLT. No package, no run. All right, so what do we see here? I didn't specify anything about the legend. You can make the legend not show up. You can have your plt.legend and have it be false so it doesn't show up. Here I made these 90 degrees. If you have long ones, you can make it 45 instead. But we can see that tool appears a lot. And then information, institution, federal, data, content, system. So really the gist we're getting here is that generative AI is a tool, okay? And that risk, bias, privacy, these are important when we are dealing with generative AI. Take a moment and do the same thing for the US and the EU. What words appear for those particular data sets? Do they use similar words? Are those words the most common?